Hello everyone and welcome to the class of Emerging Trends in Microeconomics Research. This is course Econ 413, lecture number 17, and in today's lecture we are going to discuss about the budget constraint. So let's start with it. In our previous session we discussed about the utility function and the indifference curve. On a same indifference curve, the utility is constant, whatever basket you choose, but as you move on to higher indifference curves, the utility will start increasing. Now, the basic purpose of a consumer is to maximize utility, right? And this utility can be maximized by consuming more and more of goods. Remember the axiom of non-satiability, that a consumer will always prefer more to less. So if, for example, a consumer is having 10 apples and 10 mangoes, he will always prefer 12 apples and 10 mangoes to 10 apples and 10 mangoes. Similarly, if you increase the second good or you increase both these goods in a basket, the utility will always be increasing. Now, what an individual wants is utility maximization, and utility can be maximized by consuming more and more. And if we give him the option to maximize his utility, he will try to consume more and more. That does not has any end to it. So basically the budget constraint, it actually is a kind of limitation to this axiom of consuming more and more. Budget constraint basically restricts a consumer to consume up to a certain extent, up to a certain level of goods, and that level of good should be chosen in such a way that it maximize the satisfaction of the consumer. For example, let's say we have a budget that is an individual's income that is equal to 1000 rupees or $1000, and a consumer is allowed to consume, so he can purchase two goods with it. Again, let's say that he's able to purchase apple and he's able to purchase banana with it. Now he will consume both these goods up to a level where he utilizes his entire budget of this 1000 rupees. When he utilizes this budget, he will not be able to consume more. Now he has the option either to buy certain amount of apple. Let's say he can buy 10 apples and 3 bananas, and then that may exhaust the 1000 budget. Or let's say he may consume uh, let's say 9 bananas and 9 apples and 5 bananas, and that may utilizes his entire budget. So he has multiple option. He can choose option A, option B, he may have option C, D and E and so on. Which of these options he will choose basically depends on how much utility he gets from all these options. For example, if the first basket is giving him a utility of 10, the second basket is giving him a utility of 9, and the other basket that is giving him a utility of 12. So which basket, and you know that all these baskets cost him 1000, so which of these basket he will choose? He will choose the basket that is giving him the maximum utility, and that is 12. So now we have understood the basic idea of this budget constraint. Let us formalize it. Let us give it a mathematical shape. Let us say that we have a price of apple PA, and price of banana PB. Then we have quantity of apple and we have quantity of banana. An individual has a budget, a total amount, that is Y, and this Y in our example was equivalent to 1000. So let's say his total income is Y or 1000. He will consume apple and banana in such a way that he exhausts his entire budget Y. Then we can write this mathematically as PA into QA plus PB into QB, that is equal to the entire budget Y. PA, as we said, is the price of apple. QA, as we said, is the quantity of apple. So the quantity of apple multiplied by its price is the total amount that is spent on apples. And PB is the price of banana, QB is the quantity of banana. This multiplication gives us the amount that is spent on bananas. So the amount spent on apples and amount spent of bananas is equal to the entire budget, and it can be less than the entire budget. We are able to consume less than the entire budget, and we may also consume equal to the entire budget, but we cannot consume more than our budget, our total consumption. We may also write it like less than or equal to, means our expenditure should be less than or equal to Y, but it cannot be greater than Y. We can also gain some additional information from this equation that we have discussed. That let me write the equation again. That is PA into QA plus PB into QB is equal to our total income or the total budget that we have allocated for this purchase. Now, how much of QA can we consume? How much QA can we consume and how much of the QB can we consume? So we can write this in the form of QA and QB as well. So in order to do that, let me rewrite this equation as PAQA is equal to Y minus, I have moved this here, PB QB. And in order to complete it in terms of QA, let me divide both sides by PA, and I will get Y minus PB QB, divide both sides by PA, so I will get PA over here and PB over PA over here, and on this side it will cancel out. So the total QA that we can consume depends on two things. The first is the amount, the total budget that we have divided by the price of the QA, and also on the price of QB and the amount of QB that we are consuming. Similarly, if we do it for QB, in terms of QB, we can write it as Y or PB minus PA or PB into QA. So in terms of QA, the first equation, let's call that equation 1. In terms of QB, let's call that equation 2. Now um, what else can we learn from it? Let's say that we are not consuming QB at all. We are only interested in the consumption of QA. So look at equation 1, where we have QA is equal to Y or PA minus PB or PA into QB. If we are not consuming QB, this entire term will equal to 0. Now anything multiplied by 0 equals 0. So what we are left with is QA is equal to Y or PA. What does this mean? We have our entire budget left to the QA, but it depends on the price of apples. Let me simplify this. How much QA can we consume if we have 100 rupees, whereas the price of A is 10? How many apples can we consume if we have a budget of 100 rupees and the price of one apple is 10? So 100 divided by 10 is equal to 10. We are able to consume 10 apples if we have 100 rupees and the price of apple is 10. What if the price of apple increase? Let's say instead of 10 it's 20, then we will be able to consume only 5 apples. What if our budget has increased from 100 to 1000 and the price of apple is 20? We will be able to consume 50 apples. So when we increase the budget, we will be able to consume more of those goods, and when we increase the prices of those goods, we will be able to consume less of those goods. So it is quite understandable, and we see that in our normal day-to-day routine. You can write the same for QB as well, and QB will equal to Y or PB if there is no quantity of apples consumed. So basically, this is what we can get from the budget constraint, but it is not alone. We can also have some more intuition from this equation. Now let us talk about the second perspective of the same equation. We write the equation again: PAQA plus PBQB is our total budget and equals to Y. Rearranging them, we got QA is equal to Y or PA minus PB or PA into QB. We discussed about it. That is, when we have zero consumption of banana, we will consume apples equal to this much amount, or this much units of apples. The next thing is how to interpret this ratio, the ratio of the price, that is PB or PA. So when we increase the quantity of B, when we want to consume more of B, and we have a restricted budget of 1000 rupees, and we have already allocated that budget, when we want to increase the consumption of banana, then we will decrease the consumption of apples, because we cannot consume more than the 1000 rupees, and we have already allocated this budget. So if we increase the consumption of banana, the consumption of apples should decrease. If we have infinite budget, then definitely we can keep the consumption of apples same, and we will be able to consume more of bananas. But once we have reached this equation, this limit, this constraint, then when we increase the consumption of one good, we will decrease the consumption of the second good. The question is how much decrease? So basically, when we increase QB by 1 unit, QA will be decreased by minus PB over PA. That is the price of banana to the price of apple, the ratio of the two prices. In simple words, if let's say we have price of banana equal to 10 and price of apple is 5, and we want to consume an extra banana, we want to purchase one more banana. The price of banana is 10, we need 10 rupees. The price of apple is 5. How many apples are we going uh, to sacrifice? So 5 plus 5 is equal to 10. So we will basically sacrifice these 2 apples in order to consume 1 banana. 2 apples will be sacrificed to consume 1 banana. And that is PB, that is 10 divided by 5 is equal to 2. And the minus sign indicates that we are going to sacrifice this. We'll have to decrease QA by 2 units in order to consume 1 more unit of banana. So this is basically the marginal rate of transformation. Let me write that MRT, or the marginal rate of transformation, is equal to minus PB or PA. And this means basically that the restriction imposed by the market on a consumer to transform one good into another good. In this case, to transform banana into apple, or to transform apple into banana. So marginal rate of transformation is basically the restriction by the market. Why by the market? Because both the prices are determined in the market. The price of banana and the price of apple is determined in the market. So let's say if in the market the price of banana increase, then the transformation will also change. Then the consumer will sacrifice more apple in order to consume one banana. Let us see some other perspective about this budget constraint. Again, let me write this, this equation. QA is equal to y over PA minus PB over PA into QB. Now, this equation has a certain portions. Let's say we have two variables. One is QA. We can decide between these two. We have these choices about QA and QB. PA and PB are decided by the market, whereas Y is also not in our control. So basically these are coefficients, or we may say that these are parameters that define our equation. This is parameter, and we can write this as A minus, this is our second parameter, B, and the other two, QA and QB, are variables. We can choose their value. So being variable, let me write this as y is equal to A minus BX. This is X and QA is Y. So if you look at the equation, y is equal to A minus BX, this is actually a straight line equation. Straight line equation or linear equation. Straight line equation with a negative slope. Minus b indicates that the slope of this line is negative. This is the intercept term, and b is the slope term. A will decide the intercept, B will decide the slope. And on a two-axis diagram, let me remove that. On a two-axis diagram, let's say we have um, QA over here and QB over here. This is our x-axis, this is our y-axis. The intercept term A will lie here, and here the intercept is y over PA. This intercept term over here, if we also write the second equation, this will equal to y over PB, and there is a straight line joining the two. The slope of this equation is decided by minus PB or PA. So if PB is increasing, the slope of this line will increase. If PA is increasing, the slope of this line will decrease. What does this tells us, this graph? Again, look at this upper portion, that is y over PA, the intercept term on the y-axis. It tells us the maximum amount of QA that can be consumed in the given budget, and that is when we consume 0 of QB, only consume 0, then we will be able to consume maximum of QA, and that is equal to y over PA. Similarly, y over PB, the intercept term on the x-axis, shows us how much maximum of bananas we can consume if we are not consuming any apples. So in 1000 rupees or whatever the budget, we'll be able to consume this much amount. We this graph technically seems that the price of apple and banana are equal to 1. What if the price of banana is doubled? What will happen? If the price of banana gets doubled, the slope will change and we'll be able to consume half of banana in the same budget. This was QB, QA. Then we'll be able to consume half of banana in the same budget, the 1000 rupees. And similar is true for QA. What if QA, the price of QA rises? Then again, our intercept term will start from here, and we'll be able to consume less of apples in the same budget while still able to consume the same amount of bananas. Also, there are some other points regarding the consumption. Again, we have QA and QB, and this is our budget constraint line. Let's say the price of B is more than the price of A, so we'll be consuming less of bananas and more of apple. Anyhow, now what I want to discuss here is that we have a basket. Let's say we call that basket A. Are we able to consume this A? We are not able to consume this because this is outside our budget. We do not have the right amount of budget for it to consume. So we will always consume on the red line on this budget constraint or below this constraint. Let me show you that. This is our budget line. We can consume on point A, we can consume on point B, we can consume on point C, we can consume on point D as well as on point E, but we cannot consume on point F. Why is that? F is outside our budget, but if we consume point A or on point B, the baskets, these are within the budget and these will leave us with certain amount of saving. We are not spending our entire budget. But what is common between C, D and E? All of them lie on the budget constraint. So these are the various options that will require our entire budget of 1000 rupees, but if we consume more of D, if we consume on D, we'll be consuming more apples as compared to bananas. In option C, we have somewhat equal amount of apples and bananas, whereas in option B we are consuming more bananas and we are consuming less apples. So this is how we look at the budget constraint. This is how we are going to interpret the budget constraint. Finally, we look at the impact of increasing the budget. What if your budget increases from 1000 to 2000? What will happen? So we can also show that using the same types of graph. This is our y-axis, which shows QA, and on the x-axis we had QB, and this is our initial budget constraint. Now what happens if there is a rise in the income of the individual and he is earning 2000 instead of 1000, or he is allocating 2000 instead of 1000 to his budget? So this will basically increase the overall budget. We'll move to higher budget. Let's say this is B0, so we will move to B1, our new budget constraint. What happens with this new budget constraint is that we are now able to consume more of both goods. Previously, we were not able to consume basket F because that was above the budget constraint, but now we are able to consume the amount that is corresponding to the basket F. So basically, an increase in budget allows us to increase our consumption of both goods, whereas an increase in prices, they decrease our ability to purchase, they reduce our purchasing power, and hence our budget constraint is rotated, which limit our purchasing ability of certain goods. Now we can see that in the equational form as well. Previously we had QA into PA, then PB into QB, that was entire budget that was equal to Y. Now if Y increases, we'll be able to consume more of both these goods. This increases our ability of the purchasing. In the other terms, we had QA. What about the consumption of QA? Again, that depends on Y over PA plus P minus, sorry, this is negative sign, minus PB over PA into QB. So an increase in Y increases our ability to consume more of A, and the same is true for B. An increase in Y again increase our ability to purchase more of B. But on the other hand, if you increase any of these two, PA or PB, If you increase PA, your ability to consume QA will decrease because it is in denominator. Similarly, if you increase PB, this is B, then we have QA over here, PA or PB. Then when you increase PB, your ability to consume quantity of B, that will decrease. So hope you have understood this lecture. If you have any question, do ask in the comment section. Thank you so much.